My name is Luke Seibold, this is PhyziX, and today we're going to be working on work. So first of all, what is work? Well, work is the force applied to an object through a certain displacement. So this can be written as W, or work, is equal to force times displacement. We'll give displacement as a little s. So how can we illustrate this? Well, again, let's imagine we have a box and we are going to apply a 3 Newton force on that box. So force of 3 newtons on that box. And now the force of 3 newtons is going to be applied to that box over a displacement of 4 meters. So displacement is going to be equal to 4 meters. Then once the box is moved, it will be, it'll be over here once it has been displaced 4 meters. And so, therefore, the work done will be equal to the force applied to the box times the displacement that it moved. So times 4. Now if we add in our units, we get that it is equal to 12 Newton meters. Now we know that newtons is a measure of force, and force is mass times acceleration. So the unit for newtons in standard units would be kilograms times meters per second squared, which also, and then multiply that by mass. And so that gives you 12 kilograms times meters squared per second squared. And so now we have a special unit for this that gives us we have a special unit for work that is equivalent to kilograms times meters squared per second squared, and that is called the joule. So it is 12 joules of work that was expended in moving this box from this point to this point, 4 meters. Now work is calculated using the force that is parallel to the displacement that the object has moved. So let's imagine for a sec. So in the first case, we do have an example where the force is parallel to the displacement that the box is moving. But let's imagine for a second that the force is not parallel. So let's imagine that the force is coming down at a 60-degree angle from up here. So if this is 60 degrees, and let's say that the force is 4 newtons. So now we have to figure out what this parallel component is. So to do that, we know the hypotenuse of this right angled triangle. So let's picture this is a right angled triangle, and we know the adjacent, and well, we don't know the adjacent side, but we know the angle. So if we're dealing with the hypotenuse and the adjacent side, then we'll use the cos function. So cosine theta is going to be equal to the adjacent side, which we don't know, which is going to be the f value that we're looking for, over 4 newtons. And so if we know theta is 60, then cos 60 times 4 is going to equal f. And so if we do this calculation, we find that f comes out to be 2 newtons. So the parallel component to its displacement of this force will be 2 newtons. So using that, we have a new equation. W is equal to 2 newtons times 4 meters. And so, therefore, using the unit we used before of joules, we get that the work done is 8 joules.